Sync and async may sound scary, but they are just two different approaches to handling the execution of tasks in a program. In synchronous programming, tasks are executed sequentially, one after the other. Each task must wait for the previous task to complete before it can start. In this model, the program's flow is blocked until each task finishes its execution. In asynchronous programming, tasks can be executed independently without blocking the program's flow. Each task is scheduled to run concurrently, and the program can continue its execution without waiting for a task to complete. Let's take an example with these loading images. In synchronous programming, in order to load all three images, you should wait a long time, and there is no point in this, since the loading of one image does not depend on the other one. The problem is solved by async, and all of the images load at the same time. It's always easier to understand the concept with an example in mind. So, let's say you are running a restaurant where you have to manage multiple orders, and each order goes through a few steps, taking the order, cooking the meal, and finally serving the order.
Let's start by creating a new property start time, which will represent the current datetime from date.now. This start time will be used in log function to output a text in the console alongside the elapsed time from the start, and it will be equal to date.now minus this start time. As the method does not return anything, we will put void as return type. Next, let's create a takeOrder method, which will take two arguments, a string order and a callback. Why is this callback needed, and what is a callback anyway? A callback is a mechanism that allows a function to be passed as an argument to another function. And we need it because we said previously that we need the methods to be executed one after another. And the callback helps us achieve exactly that. It's a method that will be executed later. Inside takeOrder, we use setTimeout to simulate the wait time of taking an order. After the timeout, we log the taking order action. Then we make a call to the callback function. The simulated wait time will be set to 1 second or 1000 milliseconds. Next, we will create a similar function that will simulate the cook order action. We again take a string argument named order and a callback to be executed later. We use a timeout to simulate the waiting time of cooking. After timeout, we log the cooking action and execute the callback. The timeout will be equal to 2 seconds here. Finally, we make a method to serve the order, which will be similar to the other two. We take the order argument and the callback. Inside the method, we wait 1 second, then log the action and call the callback function. Now, because we are in an Angular project, let's go to the ng-onInit method and inside it make our tests. First, we log the start of the actions. Then we call the takeOrder method. Let's say we want a pizza. After the order is taken, the next step is to cook the order, so we use the cook order as the callback. For the cook order, we use the serve order as the callback. Since we don't have anything else to do, we will use an anonymous function as a callback for the serve order and log the order served string. Now let's open up a terminal and start the Angular project using ng-serve. Then go to the browser at localhost 4200 and see how the actions are logged. Notice all the timeouts and the order of the called methods. Let's go back a little bit and look at our test code. For each action we need to execute, we append a callback to the stack. This is the beginning of what's called a callback hell, a common issue that can arise in asynchronous programming, particularly when using callbacks extensively. It refers to a situation where multiple nested callbacks are used, resulting in deeply indented and hard to read code. It's hard to read, debug and maintain, and easy to get lost and introduce some bugs. Moreover, in a real world, you can't wait for an order to finish so that you can take the next one. While you take an order, another one is cooking, and so on. Here is where promises come to save us. Promises represent the eventual completion or failure of an asynchronous operation and its resulting value. They can help clean up the code and make it easier to handle asynchronous operations. Here is how promise is defined. We have a promise object of type any that is instantiated as a new promise with two executors, resolve and reject. Now, based on some condition we want to check, we can either resolve the promise with a value or reject it, preferably with a new object of type error. Let's look how we can rewrite the restaurant example using promises. Let's remove everything from takeOrder method, remove the callback argument and replace the return type to a promise of type any. Inside the method, let's now return a new promise which will log the current action, and then set a timeout of 1 second, after which the promise will be resolved. Let's copy the same for the cook order, replacing the action string, removing the callback argument, and updating the return type to a promise of type any. And the same thing for the serve order method. Replace the code and the action string, remove the callback, and update the return type. In the onInit method, let's update the callback hell with how we should handle a promise. We first call the takeOrder asynchronous method with pizza as an argument. After that, using the then method, we will define what we want to do when the promise is resolved. We can stack multiple thens below each other. To handle an rejection, we have the catch method. And if we want to execute something after that, regardless of what happened, we have the finally method. Let's go to the browser, refresh it, and take a look. The output is the same, but notice how it becomes more readable and less error prone. But that's not it. We can make our code even more readable with the help of async and await. Async await is a syntax in JavaScript that allows you to write asynchronous code in a more synchronous manner. The async keyword is used to define a function that returns a promise, and the await keyword is used to pause the execution of the function until a promise is resolved or rejected. So here is how our code will look like with the updated syntax. In order to use await inside the method itself should be marked as async. Now let's update the promise handling with 3 new method calls. First, we await the takeOrder method for pizza, then we await the cook order for the same pizza, and last we await the serve order for the pizza. Notice how we changed our code and it looks like it's written as synchronous code now. Let's take a look in the browser. Everything should still be the same. Okay, now let's add more complexity from the real world and say that we want to process multiple orders and serve them all together for a table. So let's create an async method that will process the order and return a promise. Let's copy the 3 methods we created before into this one and of course update the arguments. Let's also copy the final log of the process order. As we said, we want to be able to process multiple orders for a table and serve them together. Let's create a new async method named manageRestaurant and inside it create 3 new orders with 3 types of food. Now, the trick to handle multiple promises at once is to use a predefined method from JavaScript called Promise.all. This method is fulfilled when all of the promises are fulfilled. So let's await the Promise.all and give it an array of our 3 orders. Let's also update the ng-onInit method and call the manageRestaurant method there. Let's open the browser again and take a look at how the promises are fulfilled together. Now, in the real world at a table there can be, and usually are, multiple people, so an order can have multiple food items. Let's adapt our code so we can take many orders with any food and serve an order after all foods are cooked. Inside manageRestaurant, let's make our order some objects with an ID and array of foods. First order will have a pizza and a salad, the second one just some burger, and the third one will be with pasta, soup and bread. Let's use the JavaScript map method to loop over the orders and map the objects to an orders array of promises from the process order method. This means we can update the Promise.all with this order array. We need to update the data types of our arguments. Let's make the order argument of type any and update the logging actions. Because of the new constraints, we need to create a cook method that will take a food argument of type string, log the action of cooking that food, and resolve the promise after a timeout of 2 seconds. This implies changes inside the cook order. Let's remove everything, and just like we did with orders before, let's map the foods inside an order to the promise resulted from the cook food method. And then await the Promise.all for all foods. Save everything, go to the browser, and here it is. our restaurant is running smoothly. Finally, let's add the possibility to deliver the orders. For this, we will create two methods. First one will be async called getDriverAvailability. Here we will simulate a route object with some drivers and the amount of seconds to wait until the driver becomes available. We then return a promise for a driver that was called as an argument. The next method will be named deliverOrder and it will also be asynchronous. We use a try catch to handle eventual errors. Inside try, we create an array of drivers. Then, in order to retrieve the first available driver, we will map the array to the result of getDriverAvailability method and give the mapped array as an argument to the Promise.any method. We previously used Promise.all to wait until all promises are resolved. Here, we wait until the first promise is resolved, and this is exactly what we want. Let's log the driver action and use the catch to log an eventual error. In manage_restaurant method, let's make a delivery for the first order. Let's also add more error handling to our code. So in the ng-on-init, let's catch and log the error if we fail to manage the restaurant. Let's also move the order process method into a try catch and log eventual errors. And here is the last test for the restaurant. Open the browser, refresh the page, and here it is. Our restaurant seems to be running successfully. Well, almost. We forgot to return the driver. Let's update the code, refresh again, and now everything is fine. Having a training example is good, but real examples are even better. So let's think of how two requests are made one after another. Request A is sent first and request B second, but somehow you get the result from B faster, and because it depends on A, you get an error. This is how you know you need promises and async await. Another example can be related to loading some scripts. Load script A is called first and script B is loaded later. You may wonder why the hell the result of script B is logged first when the order is different. Well, because the loading is done asynchronous and you need to wait for the scripts to load before you make some operations with them. That's it for a short intro of promises and async await.